Hello, this is Bunton again with your Visual Functional Mathematics at Level 1, Section 1 Numbers with Lesson 3, which is to multiply and divide by 10, 100 and so on, and then squares, and finally the rules of operations when you're doing complex mathematical calculations. In this lesson, we shall look at evidence that proves visually that a squared number is the answer to a number multiplied by itself. I said visually because I will show you proof. So let's start with multiples of tens, squares and other operation. You will learn and apply the rules of multiplying by 10, 100, 1,000, etc. You will learn and apply the rules of dividing by 10, 100, 1,000, etc. You will learn what square means and how to square numbers, and I will show you proof. You will learn how to calculate with several steps by applying BIDMAS, which is a rule you should apply to make sure that you carry out the operation in the correct order. The keywords you will come across and you need to understand and learn their meanings are square, order, operations, rules, indices, and BIDMAS. I said learn and understand their meanings because by now we know that quite often we use words. We have a sense of what they mean, but we really don't know their meanings. Let's look at how to multiply by 10, 100 and so on. A key point to remember is that all whole numbers have a decimal point of 0. For example, 33 is equal to 33.0. 65 is equal to 65.0. When we multiply by 10 or 100, all we have to do is to move the decimal points to the right. Or if we divide, we move the decimal points to the left. So to multiply by 10, move the decimal point one place to the right. To multiply by 100, you move the decimal points, yes, 2 places to the right. If you need to add zeros on the end, do so to fill the gaps. But you need to be always counting your decimal places. Let's look at some example. 33 times 10 is equal to 330. What did we do? Remember 33 is actually 33.0. So you move your decimal place past the first 0 and then past the second 0. So in this case, you have 330.0. That's actually what you have, but you do not write the 0 because it's all a whole number. 9.1 times 10 is equal to 91. 65 times 100 is equal to 6,500. And 2.3 times 100 is equal to 230. If you don't understand, can you please go through that again to make sure you get it? Try some other numbers. Anyway, we shall be doing some exercises. What I've done this time is I am giving you your practice questions in between each topic we do so that you are able to attempt them when the knowledge is fresh in your head. That way you reinforce yourself more. Not only that, but I also provide you with the answers to the practice questions on the next slide so you can compare them, and as I always say, identify the areas you need to improve on. Okay, multiplying any number by 1,000. Here, bear in mind that you must count the number of zeros in the number you're multiplying by. Then move the decimal points that number of places to the right. So if there is 3 zeros, you move the decimal point 3 places. If there is 4 zeros, as in 10,000, move the decimal point 4 places, and so on. If you need to, add zeros to the end. We'll see what that means in a minute. Let's look at this example. 49 times 1,000 is equal to 49,000. 2.59 times 1,000 is equal to 2,590. If you move your decimal point correctly, you will get the correct answer. Remember that the whole numbers always have a 0.0 after them. 1.389 times 10,000 is equal to 13,890. Let's look at some notes here. Remember to always move the decimal places this much. You move the decimal place by 1 when you're multiplying by 10, 2 places when you're multiplying by 100, 3 places when you're multiplying by 1,000, and 4 places when you're multiplying by 10,000, and so on. You can multiply by 1,000,000, by 10 million. Just make sure you count the number of zeros and move the decimal point that many places. Practice question set 1. I've given you 3 questions. The first 2 questions are just so that you're able to practice multiplying by 10 and 100, and then the second set, A to D, is so you're able to multiply by 1,000, 10,000, and 100,000. And then question 3 is an exam type question which you're likely to find. Make sure you check that when you're supposed to use a calculator and when you're not supposed to use a calculator. And the answers are on the next slide. Here is your practice question set 1 answers. Look at them, make sure you understand it. You'll observe that in question 2, the answers for question 2D, when you do your multiplication, your answer becomes millions. So you have 2,980,000 exactly. Note how we group our digits. 3 digits from the right, comma, another 3 digits from the right, comma, and then you have your million column. It's the same for the answer to question 2A. This is 65,000. Note how the digits are grouped. Now let's look at dividing. Dividing any number by 10 or 100. To divide by 10, move the decimal point 1 place to the left. Remember, it's the opposite. Now, when you are multiplying, you move it to the right, and then when you're dividing, you move it to the left. To divide by 100, move the decimal point 2 places to the left. You need to remove zeros from the ends. Okay, remember you're dividing now, so the number becomes smaller. So you remove zeros. 330 divided by 10, you just remove the 0 and it becomes 33. 91 divided by 10 becomes 9.1. We look at bigger numbers. 6,500 divided by 100 becomes 65. What did we do? We move the decimal point 2 places to the left because there are 2 zeros in 100. So 6,500 becomes 65. The same principle, 213.7 divided by 100. Now in this case, the decimal point is between 3 and 7. If you move it 2 places to the left, then it will end up between 2 and 1. And your answer will become 2.137. Do you observe we now have 3 decimal places? Bear that in mind. Dividing by 1000, etc. It's the same principle. Just make sure you are aware and you count your decimal places accurately when you're moving your decimal point to the left. And then of course, if you need to, remove zeros to make sure your answer makes sense. Let's look at the examples again. 49,000 divided by 1,000 is equal to 49 because you remove 3 zeros. You've moved your decimal point to the left. 259.6 by 1,000 becomes not 0.2596. Look at the number of hours to see the number of places you move your decimal points. 138,970 divided by 10,000 becomes 13.8970. But because the number of places ended in 0, you don't have to add that 0. You just say 13.897. Always move your decimal point this way. 1 place for 10, 2 places for 100, 3 places for 1,000, 4 places for 10,000. How many places will you move it for 100,000? Yes, 5 places because there are 5 zeros in 100,000. Got it? And here are your practice questions. Again, you've got questions 1 and 2, A, B, C, D for each, dealing with big numbers, just so that you become familiar with the number of places you should move your decimal points. And then question 3, an exam type question, which you have to think a little bit about. A 10-person team completes a 24-hour cycling race. In total, they covered 443 miles. Each person cycles the same distance. How far did each person travel? How would you do that? Yes, the answer is not the 24-hour race. The key factors here are a 10-person, that is, there are 10 people. And then the other key factor is they covered 443 miles. I've given you enough clue. You can work it out, I'm pretty sure. And there is your answer. If you did it right, you'll be happy. Don't forget to pat yourself on the back when you do good work. It's excellent practice. And of course, use the answers to find out where you went wrong if you didn't get it right. Again, it's okay to get it wrong because we learn from it. Just make sure you do the correction. Let's look at square numbers now. To square a number, you just multiply the number by itself. So 7 times 7 is 49. 15 times 15 is 225. You can check it out for yourself. You can write squared numbers using a little tool like this. So 7 squared can be written as 7 and a little 2. That is maths language you're writing in now. Okay, maths script. 15 squared can be written as 15 and a little 2. If your calculator has a button like the X squared you can see there, you can use it to square a number. Let's look at the example next door. What is 8 squared? Use your calculator, press 8 and then you do not press anything else except the X squared. It will give you 64. But if your calculator does not have that X squared, then it's not a scientific calculator. Then you have to do it manually, or you can do it manually using your calculator. Just key in 8x8. You key equals, then you'll have 64. This is the way you do it without a calculator in the exam. So you can find a square number without a calculator. Just use the method for calculation and multiply the number by itself. If it's a big number you're calculating, then follow the example you see below, example 2. We are multiplying the number you want to square by each of the multiplier, the digits on the below. In this case, you multiply 21 by 1, you put your answer, and then you go below, you multiply 21 by 2, but remember to put 0 as a placeholder under the unit column so you do not do the wrong thing. Only after you've put the 0 under the units column should you start multiplying. Then you say 2 times 1 is 2, 2 times 2 is 4. Once you've done that, you add your numbers. 21 squared will be equal to 441. Do it diligently, you will get it. And here I have a proof here that you can use to prove that square numbers are accurate. In this case, there's a draft board on the right. You count the squares along the first column of this draft board. Put your answer down, and then you count the squares along the top row of the draft board again. Multiply the answer you got for the column and the answer you got for the row, and you should have 100. This proves that 10 times 10 is 100, or 10 squared is 100. If you count the number of squares row by row or column by column, you will have 100. A common mistake people make when they have forgotten the rules of square is when they see 10 and the little 2, 10 square, they say 10 times 2. 10 times 2 is equal to 20. You will get your sums wrong. When you see 10 and the little 2 there, it means 10 times 10 is equal to 100. So this is proof of squaring. Let's look at our practice questions. You've got 2 practice questions. Question 2, calculate 23 squared. You are not supposed to use a calculator, so please, you need to show your working. As I've explained to you, you should be able to do this. Apply the manual calculation method by multiplying by the unit first, and then you go below, put a placeholder, and then you multiply by the tens on the multiplier. This is your answer for set 3. Order of operations. In maths, this is probably the strictest rule you should follow and the most useful rule, because it means that soon you'll be moving on to more complex forms of calculations. And that will involve finding squares, clearing brackets, multiplying, dividing, adding, and subtractors. There's a simple rule you have to follow. If you follow that rule, you will always get it right. So these are the 6 steps. You'll sometimes need to do calculations that have several steps. You need to be careful about the order you do calculations. If you do it in the wrong way, you might get your answer wrong. BIDMAS tells you the order in which calculations can be done. B stands for brackets, clear your brackets first, and then indices, which is for your squares and square roots. Do that sum first if you have any figures that have got squares or square roots, so you have one figure for them, and then before you divide, and then you multiply, you add, and then you subtract in that order. Point 5 explains it. And then point 6, from the left to right when multiplying, divide, adding, and subtracting. So basically you have to multiply, divide, add, and subtract, but you need to do the more complex calculations first, so you have one figure to work with for each of those sections. Order of operations. 2 examples. Example 1. Work out 4 plus 6 divided by 2. apply BIDMAS and you do the division first. Then do the addition. That is 4 plus 3 is equal to 7. Example 2. Find 8 minus 2 times 3 plus 4. Follow BIDMAS. Clear your brackets. So that would be, first of all, 8 minus 2 times 3 plus 4, or 6 times 7. 8 minus 2 is 6. 3 plus 4 is 7. And then you work out the multiplication now, which is 6 times 7 equals 42. The reason why you do the multiplication last in this case is simply because when numbers are in brackets, they should be multiplied by any other number outside the brackets. In this case, you have two numbers in brackets. 8 minus 2, which is one expression, times 3 plus 4, which is another expression. So what they're saying is, multiply, do the sum in the first brackets, you put your times table, and then you do the sum in the second brackets before you do your multiplication. So 6 times 7 is 42. Order of calculation using a calculator. This is important. Read it carefully and understand it. Calculators follow BIDMAS. Be careful when you type a calculation into your calculator. If you get it in the wrong order, your calculator will give you the wrong answer. It is not the calculator's fault, it will be your fault. If your calculator has bracket buttons, make sure you use them. The calculator will work out the bits inside the brackets before it does the rest of the calculation. So calculators are very clever. If your calculator doesn't have bracket buttons, just work out the bits in the brackets for yourself first, then enter the results in your calculator. And that is the order of operations when you use a calculator. The example, the calculator applies BIDMAS automatically. So work out the bits in brackets first. What is 1890 divided by 18 times 15 in brackets? Your answer, you type in first of all 18 times 15, which is equal to 270, and then step 2, put this answer into the calculator in place of the brackets. How you use a calculator by doing your work manually. So you'll have 1890 divided by 270 equals 7. Practice question set 4. What is 4 divided by 2 times 5? No calculator. Try to work it out for yourself. Question 2. A. 2 times 6 minus 3 times 2. And B. 2 times open bracket 6 minus 3 close brackets times 2. Question 3. What is open brackets 36 divided by 6 close brackets divided by open brackets 24 divided by 12 close brackets? Question 4. What is 52 minus 4 times 6? Question 5. Work out A. 65 divided by 5 divided by 8. And B, and 5b, what is 65 divided by open brackets 5 plus 8 close brackets? And your answers are available on the next slide, which gives you the answer. Check your answer. Pat yourself on the back for those you got right, and those you didn't, find out where you went wrong and correct your mistakes. What have we learned? Remember, I told you to always make a summary of the lesson in the way you've understood it, the topics we've covered, so that you'll be able to reflect as we progress. Once you've done that, compare it with my own summary. I might have left something out, so you can correct me. It's okay because I learn from you as well. So what have you learned? The rules of multiplying by 10 or 100 are to add the number of zeros of the multiplier to the right. In other words, you're moving your decimal point to the right and making the number bigger. You are to move the decimal points to the right as well. The rules of dividing by 10, 100, etc. is to move the decimal points to the left by the same number of zeros as the multiplier. 10, 1 0, 100, 2 zeros, and so on. Squaring a number means to multiply it by itself. The sign of squaring is to add a small 2 to the top on the right of the number you wish to square. Example, in brackets, 3 squared is 3 and the little 2 there means 3 times 3 or 3 squared. Please don't make the mistake of multiplying 3 by 2. Always apply the rules of BIDMAS when doing calculations that have several steps. If you're going to get confused, write BIDMAS down and put what they mean. You clear brackets first, then work out the indices. Indices means the squares and the square roots. You will learn about square roots later on. Work out the brackets, do the indices, that's the squares, and then you divide first, then you multiply, then you add, and finally you subtract. Follow that rule and you won't go wrong. So that's the end of our lesson for today, lesson 3. Next week we'll move on to lesson 4. I'll see you next week and take care. Thank you for attending. Goodbye.